Is this about to happen? Am I about to do every other problem on this test review to help you out? Yeah, I think so. Oh, man, we learned so much in Unit 3. We started with these operations on them. It was pretty simple. You could take f of x, rewrite it in all of its glory, and just add g of x. Simple. Just rewrite it. Do your best to make sure that the terms are like. So top down, x squared's there. This cancels, interestingly enough, leaving you with plus what's that in Spanish? Cuatro? Yeah, it is. Box it up, you're multiplying. X squared minus 4x plus dos. On the sidelines, 4x minus 2. Again, you could just FOIL this out, but I'm using box method because I think it's nice and organized. And if I need to check my phone, I know exactly where I left off. Getting 4x cubed minus 16x squared, 8x minus 2x squared, 8x, uno más tiempo, and then menos cuatro. Write it out. Yeah, 4x cubed. Combine these x squared terms. That's minus 18x squared. Combine these x terms. 16x, we're driving. And this is your final answer here. Simple, right? Now taking a difference, recall, you're allowed to say that f of x is being negated. So really, you could pop into here and say, you have 4x plus 2, and just switch the signs on everything in f of x. So now say that it's minus x squared. Instead of negative 4x, put plus 4x. Instead of positive 2, put negative 2. Getting you negative x squared plus 8x, and this cancels. So your final answer is just this. It's just that easy. Like just literally just that easy. The roots for f of x plus g of x, you have x squared plus quattro. This, you're probably not going to factor that, but you can find roots because you can set it equal to 0 and solve. So menos cuatro, take a square root, the root is on fire. X equals plus or minus square root of 4, which is also multiplying the square root of negative 1. Square root of 4 is 2. This is I. I think I'm right about this. I think you're going to do great. And there you go. Those are your roots for there. Why is this plus or minus? Because you took a square root. The idea is that you can plug in a term that's negative, square it, and get a positive outcome. And this is pivotal. So keep in mind that if you have roots, and it's so important, I'll even write it out, go back to my speaking voice. If you have one imaginary root, you better create, which is important because there are some problems where it just gives you that one of the roots is imaginary. But I would hope that since you're super smart and such a hard worker, that you look at it and say, oh, I need a negated version of that. So make sure that that appears. Okay. G of x minus f of x, what was that? Negative 8x squared plus 8x. What do they have in common? Hopefully you're saying x. And then you can keep on keeping on with this. You can set these equal to 0. So x will equal 0. If you solve negative 8x plus 8 equals 0, you get negative x equals negative 8. So x equals 8. So your two roots, here's one, here's a second. And the roots of the function f of x, x squared minus 4x plus 2, okay. You have some options here. You could use quadratic formula. You could also use a completing the square method. For this, I'm just going to use completing the square. So recall that if you complete the square, you need to add in a b over 2 fraction that's being squared, but then you also want to subtract it from that constant that's already in the problem. So allow me to demonstrate. You have x squared minus 4x. You're adding on negative 4 over 2 being squared. Write the plus 2. Also negate that fraction again. So you have x squared minus 4x. This is now doing plus 4. Still plus 2, but now minus 4. All right, so this is really x minus 2 being squared. Plus 2 minus 4 is negative 2. 2, are you? Is that really it? Negative 4x plus 2? All right, I guess that's it. So then this is negative 2. This equals 0. The hunt for x begins. Add 2 to both sides. Take a square root. Get x minus 2 equals now plus or minus square root of 2. And then add 2 over, saying that you have roots of 2 plus or minus root 2. So 2 of them. Oh, maron. Pascal's triangle for g of x to the 4th. So that's 4x plus 2 being taken to the 4th power. You have a few approaches you could do with this. The approach I'm going to do is pretty interesting, I would say. Can we factor out anything from here? Yeah, you could do 4, but let me ask, what if you did, well, sorry, you could do 2, but what if you did 4? And said that this is all still being taken to the 4th power. It makes sense. It'll work. You can say this is your A term, and we'll hold off on the 4 to the 4th. But so what I'm doing right now is saying that I want to do x plus 1/2 to the 4th power, set up a quick Pascal triangle, and I'm going to stop once I hit the 4th power. So this is 0, 1, 2, 3rd row, 4th row. Okay, so I need, all right, need an x to the 4th plus 4. A is now in the mix, so 1/2 is there. And now x cubed plus 6. 1/2 is now being squared. And then x squared plus 4. 1/2 to the 3rd times x. Almost home free. 1 is now back in the mix. And we have a to the 4th. And remember that a is 1/2. Okay, so don't forget though, because all of this still has that 4 to the 4th in the mix now. So there's going to be a lot of arithmetic along the way that you want to rewrite. You can say that this is going to be 4 to the 4th times x to the 4th. 4 times 1/2 is 2. So this is going to be 2 versions of 4 to the 4th. Because again, I'm distributing this in all over. And x cubed is still along for the ride. This is 6 times what would be 1/4, so 3/2 times 4 to the 4th, x squared. This is 4 times what's going to be 1/8, so you're now taking 1/2 of 4 to the 4th times x. And this is going to be what? 1/16. So 4 to the 4th times 1/16. Oof, it's crazy, crazy. I'll leave the arithmetic up to you to simplify. Part 1 had so much. Okay, so I'm skipping 2. I'll do 3. you should see 4 terms. So factor by grouping. Greatest common factor of these first 2 terms is x squared. That leaves you x plus 4. If we did this correctly, x plus 4 should be seen again. -2 appears. Greatest common factors get their own little house, x squared minus 2. Another factor of x plus 4. This right here, difference of squares in disguise. So don't be afraid to say that it's x minus root 2, x plus root 2, and then x plus 4. And so you'll now get 3 roots, square root of 2, negative square root of 2, -4. So this is all factored, and these are your roots. Capiche? I'm skipping 4. I don't really want to do more Pascal triangle problems, so I'm just going to do this. You see x is common with everything. Get 3x squared plus 13x minus 10. You can factor this. You do not need quadratic formula. So remember, take a times c, find factors that add up to b. There's 13, it's -30. 15 and -2 are going to work just fine. So 3x squared can be chilling. Rewrite this as now 15x minus 2x minus 10, and then x is here. Factor by grouping, take out 3x. X plus 5 appears. If we did this right, x plus 5 should be over here also. And don't forget that x is still in the mix at the front. So you have x, MVP row of 3x minus 2, and x plus 5. Set these equal to 0. You'll get 1 root of x equals 0. Also, dose thirds and -5. So 3 roots. Makes sense, right? I'm going to use synthetic division because I'm lazy. Use a root of -4. Use coefficients of 1, -3, 1, 5. Drop 1 like it's hot. -4 times 1 is -4. This gets you -7. -4 times -7 is 28. Trust me on that. 1 plus 28 is 29. -4 times 29, it's close to -120, but it's 4 away, so -116. So -111. It's left over. So lo and behold, you have a remainder. You have your constant. Notice how I'm looking at this from right to left. You have your x term. You also have x squared, okay? So if you divide this all out, x squared minus 7x plus 29 minus 111 over x plus 4. Is this what they want? That's your quotient. That's your remainder. Hopefully that's good. We already actually found f of -4 because synthetic is just cool like that. Remainder theorem is what we use to make that happen. Where if we are evaluating f of a root, this should be equal to our remainder, which again, sometimes is 0. So be open to that. Write a multiplication statement that goes with the problem. Oh, I just wrote it right here. Jeez. Let me just do that again. Multiplication statement. This times this equals that. F of x. Capiche? There's your multiplication statement. Jabroni. I'm gonna skip skip it problem 1. All right, now we're cooking. Super simple. These 3 roots. Opposite of 2 is -2. Opposite of 4 is a -4. Opposite of -2 is x plus 2. And it's factored. Nothing's mentioned about a coefficient. So there we go. It has those roots, find all root factors, and write in standard form. All right. So remember opposites of the root. We have an imaginary one, which means that we also need a second root. That's the opposite. Okay. You could FOIL this out. That'll give you x squared plus 4. And then you need to multiply it out with x minus square root of 3. So that's going to get a little ugly because there's that square root of 3 that's just going to linger. Do you have to let it linger? Do you have to? Do you have to? Yeah, you do. But not too bad to FOIL out now that I really think about it. But a minus square root of 3x squared does look a little gross. But let's keep it going. No like terms you can combine. So this all FOILed out gets you minus square root of 3x squared plus 4x minus 4 root 3. Jeez, that's crazy. Graphs. Graph this, then graph that. You want me to be real lazy and just say that's the graph of that, that's the graph of that? That'd be pretty nice, right? Don't tell me they give me a graph to do it. Oh, cool, they don't. All right, well, let's just talk about the transformations for this. This is going to go towards the right 1 unit, opposites attract, and then go up 2. This is going to do the same thing, over 1, up 2, and it's going to flip. That's why it looks that way. I should talk about, I'll do some of these, yeah. Here, what do I notice? I have to make the equation. I have a root when x is 0, and it has this bounce with me. And it's an even multiplicity because it hits and bounces. Whereas over here, when x is 3, it cruises right through, cuts through. So just keep it a multiplicity of 1. So that's that. Here, a root of x, or sorry, root of 0, root of 3. So maybe that's a good starting point. But now you have a multiplicity of 2 here. Again, because it hits and bounces like an even exponent would. So there you go. And same song and dance here. Oh, they really like these problems. Root of 0, root of 3. However, think about this. It's starting up high and ends low. So that means it has to be negative for the whole thing. And that means that we still have multiplicity of 2 when x is 3. So we need to show that. So notice how this is negative. Kind of looks like all of these, but this one being negative is a huge deal because you have to respect that end behavior. You feel me? Yeah. And number 2 above, which are the functions of going towards infinity when you approach the outwards area. So we're just looking for areas that are like going up and to the right, really. So that would be A, that would be B, that would be E, and that would be D. Is that right? X approaches infinity, f of x approaches infinity. So we're looking for graphs that are going up and to the right. So A, B, E, F of F. Those functions do just that. And those that go towards infinity when x is approaching negative infinity. That's this one and this one. So C and E. If you don't trust me, look at them again. Even in odd functions, recall that if it's an even function, if you plug in a negative version of a number and the positive version of that x coordinate is going to be the same outcome. Odd says that if you plug in negative x, it really makes the whole function, or if you evaluated the positive version, it's just the negative version of it. So let's check these out. So what do we have? This looks like a sine function. It looks as if there's some symmetry, but I'm going to go ahead and say, well, let's check some points. We know that there's this 1 point, what is it? 1.45-ish? Approximately, that goes to 1. So we know that f of x could equal 1. And if we evaluate f of negative 1.45, that hits us to negative 1. So thinking about this, negative 1.45 comma negative 1. So this is saying that f of 1.45 equals 1, but f of the negative 1.45 equals negative 1. Oh my, what are we able to say? Are we able to say anything? They're not equal, so this is definitely not even. Is f, yeah, I think it might, yeah, I think we're able to say that it's odd. If you really think about this, because we evaluated f of the negative number, and that's equal to the negative version of the positive input. So negative 1. Yeah, so it's odd. Boom, there you go. We're probably going to see some symmetry here. The same outcomes produced, like this point here. Let's call this negative 0.75 as the same outcome here. So even. This is, and you can even like double check, like this is going to be when x is 2, it's the same outcome when x is negative 2. I guess you could think of it as like they're on the same wavelength. It's kind of an interesting way to think about it. Mostly, again, it's split around the y-axis. That's another important thing to mention. What is this? This is a q quadratic that's shifted down 3 units. I think it's just x squared minus 3, right? So let's check. We plug in where x is negative 1. It's the same output as when x is 1, right? So probably going to be even. And again, it's not just because the exponent's even. This could have easily been shifted left or right, and that would throw things to a different situation. But again, you can always think about testing some points like this negative 1.75 as the same out point as this positive 1.75. So those are things that you can use to help you out. I'm going to skip D. I don't feel like doing much more. If this is even, negative 1 should go to 1. Negative 2 should go to 3. And should behave like a quadratic. You know, of course, hitting the points. I think I covered enough for today, right? As I try to battle with this point. If you actually watch the whole thing, that's pretty impressive. I applaud you for that. Thank you so much for tuning in, following along. Take care, brush your hair.